We talked about arithmetic and geometric series in class, so I don't think this is going to be shockingly new to anybody, but I did just want to run through a couple of examples here just in case you needed to see them, just to have these available as a resource. Remember, arithmetic sequences, you can take the first term, you can add the common difference times one less than the number of terms in the sequence to get the next term in the sequence, the nth term. The sum, you can add the first value and the last value of your sequence and multiply by the number of pairs, and that would add up, n terms of the series. For a geometric sequence, you can take the first term times the common ratio to the n minus 1 power, because you already have the first term, you're going to multiply by r one less times than the number of terms in the sequence. Pretty much just need another formula, a sub 1 times 1 minus r to the n over 1 minus r. The sum of infinitely many terms, and you do have to be careful here, this only works if r is between 1 and negative 1. You've got to have terms that are decreasing, approaching 0. But if you want the sum of infinitely many terms of a decreasing series, you can take the first term divided by 1 minus the common ratio. So anyway, run through a couple of examples here real quick. If I want to find the sum of the first 20 terms, first of all, I need to find the 20th term. So I can take my first term of negative 3, and if you notice here, this is an arithmetic sequence. We're adding 5 each time. So I'm going to add 5 19 times because I already have the first term. So I'm going to add 19 5s, okay? And notice, by the way, that's what the formula says. Take the first term, 1 minus the number of terms you want. That's 19 times the common difference, okay? 5 times 19 is 95. 95 plus negative 3 is 92, okay? So my 20th term here is going to end up being 92. So notice for the arithmetic sum formula, you need the last term. I need the 20th term to be able to find the sum in this particular case, okay? So once I know that, I can go back and I can use the formula. You're going to take the first term of your series, which is negative 3, plus the last term of your series, and you're going to multiply by the number of pairs. Okay, we've got 20 values. That means they're going to be 10 pairs. So in this particular case, that's 89. 89 times 10 ends up equaling 890. Okay, that would be the sum of the first 20 terms of that arithmetic sequence. Okay, for the second part here, it's geometric, and you do need to figure out what your common ratio is. Remember, you can always take the second term divided by the first, or the third divided by the second, or whatever term divided by the one that comes before it. And so, for example, 6 over 4 here, 6 divided by 4 is 3 halves, okay, or 1.5. So that's what I'm multiplying by each time to get to the next term. So if I want the 10th term here, I already have the first term, so I'm going to multiply by 3 halves 9 times, okay? It's the first term times the common ratio to the n minus 1 power. Okay, so I wanted to take that to the 9th power. Or you could take 1.5 to the 9th power. And you're going to get some pretty big values pretty quickly here, although in this case it's not massive. You also get a lot of decimals. So this looks like it's going to be about 153.77 if you round to 2 decimal places. Okay, so mostly just putting the values into the formula. For the sum of 10 terms, you're really just going to need to substitute into the formula. And one of the interesting things is that you don't actually need the nth term here, unlike you do in the arithmetic sequence formula. So really we can just kind of drop everything in here. First term is 4. 1 minus the common ratio to the n power. So the common ratio is 3 halves. The ratio, the power there is the 10th power. And then you're going to divide by 1 minus the common ratio, 1 minus 3 halves, and we just have to be careful here when we evaluate this. So that's going to be 1 minus 1.5 to the 10th power. That's probably what I do first. You're going to get a negative number. Multiply that by 4. Okay, it'll still be negative, but the denominator is also going to be negative. 1 minus 1.5 is negative 0.5, so I'm going to divide by negative 0.5, which will end up giving me a positive answer. It's about 453.32. Okay, sorry about that. 453.32 is my final answer. All right, so mostly just plug and chug. The last one here, I do have a geometric series that is infinite. I want to take a look at that one real quick. The one that I chose here, and I wrote this down, I thought I'd pick one that was maybe a little bit messier. So I've got one that's 125 minus 100 plus 80 and minus, this will be an alternating series. In other words, it's going to basically have a negative r value. It's going to alternate back and forth between positive and negative values. Okay, you do need to check to see that the individual terms are decreasing. That is, that common ratio is somewhere between -1 and 1, or sometimes we'll say the absolute value of r is less than 1. So anyway, we should be able to take the second term divided by the first, or the third divided by the second. I actually like this here. Third divided by the second would end up giving us -0.8 or -4/5. Okay, so this is a decreasing series, except because you have a negative multiplier there, it'll alternate between positive and negative. All right, so that's my r value. All right, and should just be able to pop everything in the formula here. Should work out real nicely. The formula says take your first term. My first term in this case is 125, and divided by 1 minus the common ratio. Now be careful here, because it's an alternating series, my common ratio is -4/5. Okay, so it's going to be 125 divided by 1 minus -4/5. Okay, that is actually the same thing as 1 plus 4/5, or 1 and 4/5. Okay, so that's going to be 125 divided by 1 and 4/5, or divided by 9/5. Anyway, in this case, we're dividing by a fraction here, so we can multiply by the reciprocal. And the final answer is going to be ugly. 5 times 125, I believe, is 625. It's just going to be 625 over 9 ends up being the final result. So, you know, certainly if you needed a decimal for some reason, you could divide that out. But that's the basic idea. So again, formula is pretty easy to work with. You know, obviously if r is like a half or something like that, it can be simple enough that you can almost do it in your head. But thought I'd do a little tougher one here, and hopefully that was helpful.